My name is Boris, I'm the team captain, and this is our proud creation. Being the team leader, I was in charge of documenting the group's weekly reports, as well as ensuring that all the assessments were done and handed in on time. I also assisted with the software involved in the robot and the general assembly of the mechanical and electronic parts.
I'm George, and I was in charge of the electronics of the robot. My job was to ensure that the hardware was reliable, neat and compact, so that the robot would be equipped to give us the best performance possible. My jobs included the design and making of the color sensing modules and the layout of the main circuit design of both VeriBoard and PCB. I also assisted with the software development of the robot.
I'm Jeff, and I was in charge of the mechanical design of the robot. My tasks include the design and the assembly of the grabber arm system and the 2-axis lifting system. I placed all the mechanical parts in the robot considering the weight balance and how the robot will approach the pucks. And I also assisted with the coding as well. That's it.
So we'll start off with our PCB. We chose to use an etching technique to make our light detecting circuits because we believed that it was a very efficient method to do so. There's an image of what our trucks look like, and here in this next photo is what the case looked like. The case was important because it was used to deflect all of the light that was ambient, not used in the design. We also used a VeriBoard to make our second light detecting circuit. It was actually developed first and chosen to be used throughout the rest of the design because it worked so well and so much better than our PCB. So this is the schematic of our system. We used it to design our PCB, and this is what it looks like when it was being routed. So that's the auto router being used, which was very useful, and that is what the actual circuit ended up looking like after we printed it. So after we printed it, we used an etching technique to reveal the copper traces so that it could be soldered. But unfortunately, the soldering didn't work, and we had to stick to a VeriBoard system. Unfortunately, the PCB didn't work, so we had to resort to a breadboard version of the robot. This was an unfortunate flaw in our design, but it was something that we had to do in order to satisfy the requirements. In future, we would do our VeriBoard or our PCB much earlier on so that we would be able to take into account any. So this is what the final render of our design looked like. You can see that we have 3 ultrasonics on the sides and back, and well, there should be 2 at the front. So looking at the grabber arm, you can see that it can be raised up and down, but it can also be moved left and right if you can see the second stepper motor behind that big block in the center. This adds versatility and makes it a whole lot more useful, as the robot does not need to move left and right. It can just use the stepper motors to pick up all 3 pucks. The weight distribution as well, 1 stepper motor's at the back, 1's at the right, so that it's all balanced around the center of the axles. Moving on to the grabber arm, we can see that the arm that actually rotates with the servo is bended inwards. This allows the puck, when grabbed at a position that isn't optimal, to still be captured and pulled into the center of the puck so that the location of it when it's in the hands of the arm is predictable. This makes it a very efficient design, and it's also very simple but effective. Here's a short clip of the robot moving and picking up a puck. So it's rotated, it's gone into the zone, it's closed the servo arm, it's lifted upwards, and that's how it locks onto the puck. So as we ran a little bit late with our PCB design, we had to take the robot home over the weekend, design our own arena, and test it out. It worked quite well and helped us get to where we needed to go. Here are some final images. This is what the breadboard looked like when we designed it. This is what the final arm looks like close up. It's made of acrylic and 3D printed materials. This is a close-up of the breadboard with some of the components we had to add. And these are some short videos of our team assembling and soldering and typing and doing various things to design and make the system. And here's a clip of us trying to figure out what parts to use. And thank you for watching. We hope you've enjoyed the video, and thank you. Goodbye.